everyone, welcome to this session number 364. And today we continue with this problem. Is the shortest path in a grid with obstacle elimination. And yesterday I had the idea to okay, come on. Okay, to use an array to define these possible paths. Let me explain here. Okay. Basically, is that okay. The idea behind this, okay, is that every cell, will contain an array with, in this case, for example, if k is equal 6, an array with 6 elements. Yeah, in this case, like this. No. Okay. Basically, this is inside this. Okay. And the first, it's a matrix where every cell contains 2 slots. Okay. Well, in this case, for the first register, like this, the first slot is for define the number of k. Yeah, in this case, for example, the first time is here. What is the number of k? In this case, is the 6. Okay, in this register, we can put the in this case the steps 0. 0, yeah, because we start here in 0. Now if we move to this direction, it's basically another matrix where here is, okay, how many k we have? Okay, we have the 6. Okay, in this register 6, we can put 0 and in steps 1. Now, for example, what happened when I move in this direction? Yeah, we found a wall. In this case, we have another. Yeah, and in this point, we need to check. Okay, how many is 6 less 1 is 5. Okay, in this register is 1 and 0. Yeah, and if we move in this direction, basically is. For this is we have 2, 0. Sorry, is 6 less 2, it's equal 4. Do you imagine that here is, okay, 2 and 0. What is the reason of this? Because in one moment, for example, I can down in this direction, yeah, and find that what is the minimum, this or this, yeah, because for example, if I start here and I move here, yeah, for example, this is one path, 1 0 1 2, yeah, or another path will be 0 1 2, or another is 1 2. But you know what? Okay, the first, let me change this. 0, for example, 0 1 2 1 2 3 2 3 4. Sorry, I forget to check the Twitch. Okay, now okay, we're back here. We have this, means that what happened, for example, if I ignore completely the walls, for example, 0, 1, 2, 3, 4, 5, and 6. And in this case, we have 2 and 4. And this is the shortest path, 0. But what happened, for example, where k is equal, instead at 6 is equal to, yeah, and we start here, the shortest path could be 0, 1, 2, 4, 5, 6 in 6 steps. But in having, for example, k less 1. But for example, do you imagine that we have k is equal k is equal 1, and here this is a wall, this is a wall, and this is a wall. Yeah, in this case we can cross, you know. If we start here, basically it's 0, 1, 2, 3, but this is k is equal 0 here. We can move it to the next if the k is equal 0. In this case, come back to the right is not possible, to down not, to right not, to top no. Okay, come back to this is full, come back to this. I can. Now, at this moment, for example, I can, because the k less 1 is in this point. Okay, I think that okay, I think that it's only tracking the current step and the current k, yeah, and that's it, I think. Because if we start, for example, the first number, let me explain it here. X and Y, these steps in this residual, no, K. Yeah, in this case, the first time steps is 0 and k is equal 0, because it's not a wall. Yeah, what happens if I need to move to the right? I can move to the right. What is the conditional? The conditional is basically if the number of k is greater than 0. Yeah, in this case is greater than 0, or is empty. Yeah, in this case is empty, means that I can move to this direction, 1 and 0. Now again, this can move to the right, yeah, because both conditional, one of the two conditional are true. In this case, both are true. Okay, we can move this 2 and 0. Now to the right, I can move, no. To bottom, yeah, in this case is 3, 0. I can move to the left, yeah, to the right, sorry. Okay, sorry. I am here. I am here, yeah. I can move to the right, no. To the bottom, yeah. The direction right now is this. This doesn't matter the order, but in this case is right, no. Bottom, yeah. Okay, 3, no. Here is 4, 0. To the right, no. To the bottom, in this case, for example, to the bottom is possible. Sorry. Okay, I can change the conditional. In this case, meanwhile k it's minor that K, that in this case is 6. This case, the first time is starting 0, 0, 0, 0. This case is 0. I can move to the right, no, to the bottom. In this case, I can move because, yeah, because is 4 plus 1 is 5, and here is 1. Yeah, I can move to the right, no, to the bottom. Yeah, in this case, 6, 1. Yeah, and now, for example, I reach this, but let me check the other paths. Okay, I reach this. For example, if I come back to this, in this case, go to this. In this case, is 1 and 1. And I think that, is yeah, for example, here, if I start in 0, 0, 1, 0, and I move to down, should be 2, 1. Yeah, because K, I have that. In this case, if I start here and I move down and move to the right, in this case should we have 2, 2. Okay. Okay. We start with 0, 0, 0, 1, no, 1, 0, 2, 0, and in this case, for example, if this is stop, come back to this, here is 1, 1, 2, 2, blah, 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 blah. And now this, in this case, is the shortest path, means that the element that the mean steps that reach this position will be the result. Means that I will get many results for the many paths, but basically it's only count. Yeah. Okay, if I start here and I take the path that cross all the blocks is 0, 1, 2, 3, 4, 5, 6. This will happen, but in this case the number of the steps is 6 and the number of the blocks that cross is 4. Here I can invalidate this path if this is greater than the original K. And next to is moved in other direction, in other direction, in other direction. I think that is very expensive, this, but it's my solution right now. Okay. Okay, sorry. Now, come back to this. I think that the first is declare the directions. Directions. Sorry. In this case is basically this. left in this case is less 1, less 1 0, top is the first is the row. The next is the top, means that this is 0 and this is 1. To the right in this case will be 1 0, and the last is to bottom is 0 less 1. Now in this case is bottom. Okay, let me do again this. For the left, this is the column, means that less 1 left. Top, I need to increase the column, the row, sorry, is this. The next that is left, top, right. In this case the right is this and the bottom is this. It doesn't matter the order, but usually I use this distribution. Well, now what is the next? Sorry. The next is we have the directions, and basically I need to let me check this BVS. If I start here, I have double here because I am applying the DVS, this case BVS. Why? I think that is because if I search the path, or if the current path is rebase the number of blocks that I can break, don't make sense continue with this path. But okay, we start with the first. I think that I have my mind right now a little confusing. Okay, we have the directions, and if I apply the BVS, for example, it's basically take this and apply the operation of add in the queue with the number of steps and blah blah blah, and next to is okay, this check the options of this, and that's it. And in this case is this. If I start here, I check left is possible, no, because it's out range. Top is possible, no, the same, is out range. Right is possible, yeah, it's here, okay. Is add in the queue. And bottom is possible, yeah, because have this. And now is complete. Now move to the next, that is this. Now this to the left is possible now because has been visited. Okay, we need the hash set for define this position. bottom top is I can validate bottom, the top no, the right yeah, okay, is is add in the queue, and bottom yeah is possible and is add in the queue, but in this case every time that I add this to the queue is basically updating the number of steps and the number of the blocks, or in this case k. Oh my god. Okay, if we start with the first, validate, add in the queue, in the bottom, add in the queue. Now move to the next. The right is possible, yeah, add in the queue. The bottom is possible, yeah, add in the queue, but with this position. Now the next step is this. Yeah, I think that is this is the right. But in this case, I'm not sure if the hash set, because for example I am here and move to the next and move to the next. Yeah, because if I mark this as a scene before, when I, for example this, when I move to the next I mark as a scene, but for example if this want to cross for this can be possible because has been visited before. Or I can save the, instead only save the position in the hash set, the first, well, position, no, row, call, and steps. Yeah, means that for example if I am here and I reach this block with 2 steps and only one block broken, I can make this specifically with this number of, no, this is steps and this is k. Yeah, I reach this block taking 2 steps and win 1k. But what happened when I move to this, and this is different because the steps are 1 and 2 but with k in 2. Yeah, okay, in this case integer is of the tree, scene. Now scene is equal new hash set. Yeah, now the next that is queue. No, integer, I think that is the same, an integer with 3, no, with 4 slots. Queue is equal new linked list, linked list. Okay. Now the next step is basically add q.add, and in this case is new int, and the size is 0 0 steps 0, and okay, here is 0 plus, and in this case I need to validate the position. Grid in the position 0 1, no, 0 0 0 0 is this. If this it's equal, come on, it's equal that 1 is add plus 1, other case is 0. If this is a wall, basically 0 plus the wall. In other case is 0 plus 0, that is still in the same. Yeah, and this is okay. Now while q is empty but negative, yeah, in this case is integer node, it's equal q dot remove, no, integer size, it's equal q dot size, and next to is the 4, here is integer I, it's equal 0, while I it's minor that size I plus plus, and in this case is I remove the node. Yeah, in this case this node the first time contain 0 0 0 0, all of them is 0. Yeah, and we need to check the directions for integer directions. Yeah, and next to is validate if is valid. What means valid is basically integer new row, it's equal direction in the position 0, and new column. Yeah, represent what is the next cell. If I am here and the next is, or the first direction that I want to check is the left, is basically this, and here is new row, new column, and with this basically is a function that I will create here. Private boolean is valid or is in range, integer row, integer call, and I forget the create the size here, row n, integer m, basically is the size of the matrix, and it's equal grid dot length, and m it's equal grid in the position 0 dot length. Yeah, okay, now I have the access to know what is the size of the current matrix. In this case return where row its minor is greater equal 0, and row it's minor that n. This is a positive. First is m and n, m and n, yeah, and call should be greater equal to 0 and call will be minor that n. In the case that is inside the range, it's valid. And here I need to check what is the here I need to check if I can continue checking this if it's inside the grid, but if the number of blocks is still valid. Yeah, for example, okay, here I need two validation. The first is that if new row, this is I need to add the all div. Yeah, basically is plus the node. If I am here and I need to move to the left, is basically take this plus this direction. And in this case I am only take the, yeah, well, even let me create or take directly integer all row is equal node in the position 0 1 2, no, 0 integer all call is equal node in the position 1, basically is here all row plus this all call plus this. Yeah, okay, now it's right. Now if a new row grid in the position new row new call it's equal 0, or if grid in this position new row new call no, this is wrong. If happen this, or where is a 0 you can continue, but when you have in this case node in the position first is row column steps and the next that is k is the 4 0 1 2 0 1 2 3 is in the index 3, it's minor that k. Yeah, and if it's minor than k, yeah, because for example if don't cross this if don't pass at this validation because it's a wall, I need to check this. Oh, but in this case it's +1. Yeah, because if this is false means that is a wall, I can increasing 1 and valid. Okay, is inside this. In the case that is valid, I can continue. In the case that, for example, you reach the maximum number of blocks that you can break, don't make sense that continue, you know. If, for example, k is equal 1 and you are here and you need to move to this, it's not possible, basically. Now here, when it's valid, I need to add in the queue. The first is scene.add new int, and basically new row, new call, node in the position integer steps it's equal node in the index 2 integer counter it's equal node in the position 3. Counter means a current blocks, yeah. In this case is new row, new column, steps +1, and the next that is counter, but in this case counter plus equal, and I need check if this is true. No, sorry, this, if this is equal to 1, okay, +1, in other case +0. Yeah, and and I need to add q.add I think that integer array, here array and array. Okay, we have the size, we have this iteration, and okay, but in this case what is the result that I need to return? The number of steps. Okay, here is integer result, it's equal here should be integer dot max value, because we need to return the minimum. And here I'm not sure is inside this or in this. I will put here if the position, what is the position of this, is basically if all row it's equal m and all call it's equal n. Basically, for example, the number of row here, the size, the length is 1 2 3 4 5, and this is 1 2 3. Here is less 1. Basically is this here, this position. If it's this position, I need to check n, and the number of the counter will be minor than k. Yeah, in this case what happened is, I think that maybe this is optional, but well, result it's equal math.min result and steps. Yeah, and in the case that here return result it's equal to math.max value value, then less 1 other case result. Okay, this is hard. Okay, What do you think? You think that makes sense or not? Okay, double check. Row, column, steps, K. We have the directions in. We take the size of the matrix. We have the result. Here is the mean. The result, the Q for save this. Now we start with the first element. This, for example, is 6y. 1, 2, 3, 4, 5, 6. This is 0. 0, 1, 2, 3, 4, 5, 6. 0, 1, 2, 3, 4, 5, 6. It's okay, this 0, 0, 0, 0, and this. Now we remove this, and we have the values, we have the directions, new direction. We need to validate this. What is one is add this, is add and add. Yeah, I think that makes sense. Let me check. I don't see the bottom. Damn. What? Max value. What else? What? If it's equal 1, then 1. Other case 0. This is okay. No. This is wrong. It's here. Okay, I think that. Come on. New. Yeah, it's right. Q. What? Q dot add array. Yeah, it's because was integer. Come on. Max value. Cannot find the symbol. I wrote. Yeah, it's integer. Please, please, please. Okay. Why? Why? I think that is for this, but I'm not sure why. Never end. Or in this case, it's time limit exit, but why? Maybe it's for this. Okay, what do you think if I move this? I create a register here and only save in the queue where it's valid but mark as a visit all the time. No, for this, no. Okay, I need to valid here and have another if here for for add in the queue. I need this. Oh, I know what. It's because I need mark the all direction here. Here I think that is a node is marked as a visit. No. But yeah, in this case I need mark this node as a visit in this moment, and I think I was right with this validation in the top. It makes sense continue with this nested validation if I can have it this way. Yeah, sure. I am using this, but in any moment I am compared with the them. Okay, here is scene dot contains I think that is in the final. N, this is an N. Scene contains new int. In this case is new row, new call. Yeah, basically this. No. Okay, let me divide because it's not compressible this way. Okay, much better. Well, at least I don't have more this timeline exit. Now here is less one is 6. Why never happened this? Why is one? Oh. Why never reach this? Let me check. Why? I will put inside this, and is new row. No, is out. A row in this case is 0, 1, 2, 3, and 4. This case is less 1. Yeah, it's less 1. This is less 1. Let me check on it. What? Never cross this conditional, but why? It's not for this because I remove it and it's the same result. It's for this, but why? Row is greater than equal 0 and row is minor than m. Call is greater than equal 0 and call is minor than n. This is right. Now here is valid. Is this or node in the index tree? This is or counter plus 1. It's minor than this. Only for be sure. Let me change this. Only add this conditional. I think that is not, don't make any difference. And sync hasn't been checked before. I don't see my error. Where I added this? But why don't reach this? This is right. We mark this as a visit now. The direction and it's the current direction. It's valid. The grid is this. And it's not contained in the scene. New row, steps plus 1, counter plus equal. Okay, here it's only plus. Where is 1 is plus 1, where is 0 is plus 0, and add in the queue. Okay. Okay, what is this? All row 0 0. Okay, it's the first. And that's it. Why? Q. I don't see my error. Only one time. Why? If I put here, if is the new row, new column, and is valid, basically here, new row, new column, and counter. Array in index 0, array in the index 1, array in the index 0, 1, 2, 3, and this is array in the index 2. I'm not sure why, but don't reach this position. Don't reach over is false all the time. Okay, well, I think that I will continue in the next transmission, and well, thanks for following this transmission, and I hope see you in the next. Bye bye.